There are three hyperbolic identities that are similar to the Pythagorean identity, sine squared of x plus cosine squared of x equals 1, as well as the two related trig identities that I'm going to introduce in this video. Recall that the hyperbolic functions, sinh of x and cosh of x, are defined in terms of exponential functions, and tanh of x, sech of x, cosech of x, and coth of x are defined in terms of sinh of x and cosh of x. So the trigonometric Pythagorean identity is sine squared of x plus cosine squared of x equals 1, and the two related identities are tangent squared of x plus 1 equals secant squared of x, and cotangent squared of x plus 1 equals cosecant squared of x. These two identities are derived using the Pythagorean identity, and it turns out that there are three identities similar to these ones for hyperbolic functions. The hyperbolic identities analogous to the trigonometric identities are cosh squared of x minus sinh squared of x equals 1, 1 minus tanh squared of x equals sech squared of x, and cosh squared of x minus 1 equals cosech squared of x. They're similar to the trigonometric identities I mentioned earlier, but with a negative sign in front of one of the terms instead. So what I'll do now is prove each one. So let's start by proving cosh squared of x minus sinh squared of x equals 1, which is the hyperbolic version of the Pythagorean identity. If we start with cosh squared of x minus sinh squared of x, we can substitute the definitions of sinh of x and cosh of x to rewrite this as e to the x plus e to the negative x over 2 all squared minus e to the x minus e to the negative x all over 2 all squared, because recall that sinh of x is defined as e to the x minus e to the negative x all over 2, and cosh of x is defined as e to the x plus e to the negative x all over 2. If we expand the two terms using the perfect square formulas, then e to the x plus e to the negative x all squared is equal to e to the 2x plus 2 times e to the x times e to the negative x plus e to the negative 2x, and this is all divided by 2 squared, which is equal to 4, and then minus e to the x minus e to the negative x all squared, which is e to the 2x minus 2 times e to the x times e to the negative x plus e to the negative 2x, and this is all divided by 2 squared, which is equal to 4. And this is of course because e to the x all squared equals e to the 2x, and e to the negative x all squared equals e to the negative 2x using exponent laws. We can simplify the 2 times e to the x times e to the negative x terms as 2, because e to the x times e to the negative x equals 1 using exponent laws. So we can simplify the expression as e to the 2x plus 2 plus e to the negative 2x all divided by 4 minus e to the 2x minus 2 plus e to the negative 2x all divided by 4. If we combine the fractions with the same denominator, this is simply equal to e to the 2x plus 2 plus e to the negative 2x minus e to the 2x plus 2 minus e to the negative 2x all divided by 4. And notice how I distributed the negative sign into the second term. So we can cancel out some terms and rewrite the entire expression as 2 plus 2 all over 4, since e to the 2x cancels out with the minus e to the 2x, and the e to the negative 2x also cancels out with the negative e to the negative 2x. So we're just left with 2 plus 2 in the numerator. So this is just 2 plus 2 over 4, which is equal to 4 over 4, which equals 1. So we started off with cosh squared of x minus sinh squared of x, and we ended up with 1. So this means we can confirm that cosh squared of x minus sinh squared of x equals 1. So now we can use the identity cosh squared of x minus sinh squared of x equals 1 to prove the other two hyperbolic identities I introduced earlier. I'll start by proving 1 minus tanh squared of x equals sech squared of x. If we start with the identity cosh squared of x minus sinh squared of x equals 1, we can divide both sides of the identity by cosh squared of x, which turns the identity into cosh squared of x divided by cosh squared of x minus sinh squared of x over cosh squared of x equals 1 over cosh squared of x. cosh square root of x over cosh square root of x is equal to 1, and we can rewrite sinh square root of x over cosh square root of x as sinh of x over cosh of x all squared, and the right-hand side, 1 over cosh square root of x, can be written as 1 over cosh of x all squared. Recall that sinh of x over cosh of x is just the definition of tan of x, so we can rewrite the sinh of x over cosh of x all squared term as tan of x all squared, which is just tan squared of x, and 1 over cosh of x is the definition of sech of x. So 1 over cosh of x all squared is just sech of x all squared, or sech squared of x. So this means 1 minus tan squared of x equals sech squared of x, which is the identity we were trying to prove. The other related identity we need to prove is cosh squared of x minus 1 equals cosech squared of x. If we start with the proven identity, cosh squared of x minus sinh squared of x equals 1, we can divide both sides of the identity by sinh squared of x. This results in the identity cosh squared of x over sinh squared of x minus sinh squared of x over sinh squared of x equals 1 over sinh squared of x. Cosh squared of x over sinh squared of x can be rewritten as cosh of x over sinh of x all squared, and sinh squared of x over sinh squared of x is just equal to 1. So the left-hand side is just cosh of x over sinh of x all squared minus 1. And 1 over sinh squared of x on the right-hand side can be rewritten as 1 over sinh of x all squared. Notice how cosh of x over sinh of x is the definition of cosh of x. So cosh of x over sinh of x all squared can be rewritten as cosh of x all squared, or cosh squared of x. And the minus 1 stays the same. And 1 over sinh of x is the definition of cosech of x. So we can rewrite 1 over sinh of x all squared as cosech of x all squared, or cosech squared of x. So the identity becomes cosh squared of x minus 1 equals cosech squared of x, which is the identity we were trying to prove. So to recap, the 3 hyperbolic identities introduced were cosh squared of x minus sinh squared of x equals 1, 1 minus tan squared of x equals sech squared of x, and cosh squared of x minus 1 equals cosech squared of x. The first one was proven using the definitions of sinh of x and cosh of x in terms of exponential functions, and the other two were proved using the first identity.